So when you talk about radar, we have seen that radar can be operated with two different type of signals. That is, one is in the form of a pulse, one is continuous. Now, what kind of signal we are using, we are going to name that radar. So one is pulse radar. The name itself suggests that we are going to use pulses here. Next is continuous wave radar. Very clearly it says it's a continuous wave. That is, it will be using analog signal. So here, when we go ahead with the pulse radar, now this radar, as we say, will be using the pulses, and depending upon what application we are using for, we are using these pulses. So, like one is for fixed target, one is for moving target. So here, purely based on the target, is it moving or fixed? We are going to use these pulses. Now, next, if we know more about fixed target if you are going ahead. Now, when we talk about fixed target, there are many applications like when we talk about mines or when we talk about an earth structure, a terrain, then we know like mountains are going to remain fixed. And mostly we use geostationary satellite, which will always be placed above that particular terrain. And as the rotate, we know that when you talk about geosatellite, the way it revolves and the rotation of the earth is mostly similar. They take care of 24 hours. So what happens is when the earth is taking a rotation of 24 hours, it the satellite also takes 24 hours for revolution. So this rotation and revolution, since they are relative to each other, it always look like they are above it. So for such fixed targets, we use pulse radar. So, and fixed pulse, we are using pulses. So now how is it work? So this is your block diagram. We know that duplexer is a switch which switches between a transmitter and a receiver. That all depends upon how the signal is coming. Now, if a transmitter is sending pulses, then duplexer will turn on and it will allow these pulses to go towards the antenna for transmission. Now, for that, what is needed? When we talk about transmitter, we need a pulse modulator which will be sending very high frequency pulses that increases the strength of a signal so that it can travel for a longer distance. Now, then duplexer, which is already a microwave switch. Microwave switch means it's a very high frequency switch and it works for a very high frequency. So when we know that when we are sending a signal into the space, the strength of a signal needs to be very strong. So this duplexer, being a microwave switch, takes care of this very high frequency, turns off the receiver, turns on the transmitter, and transmits the signal towards the antenna where it gets dissipated to into the space. Now that was all about transmitter. Now when we talk about receiver, when the signal is been received by the antenna, the duplexer turns off the transmitter, turns on the receiver, and the signal goes to low noise RF amplifier, where the weak RF signals have been amplified. Now, further, these signals go to a mixer where it produces the sum and difference of those frequencies. And then it that leads to a intermediate frequency. Now, then we have a local oscillator which produces a constant high frequency which gives it to mixer. This actually helps to produce the IF frequency. Then Then we have IF amplifier, which we called it as intermediate frequency, which we have received from mixer. Now this amplifier improves the strength of this IF amplifier so that signal to noise ratio also improves. Now detector, it detects this IF amplifier, right? And further detecting this signal, it demodulates the signal first and then goes to a video amplifier. This video amplifier is basically a where the output is been displayed. Now it can be in audio form or it can be in a display form. So that is how the um, our pulse radar works. Now, when we talk about moving target, now here it's already been said that the target is moving. Now, here Doppler effect plays a role. So, in the previous class, we have seen that moving target indicator is a target which is moving continuously, and this radar, with the help of pulses, is going to receive all the information about this moving target. How is it going to do? It is going to do with the help of Doppler effect. What is a Doppler effect? Basically, Doppler effect is when the object is moving towards you or going away from you, there is an apparent shift in the frequency. This frequency is being detected, and this entire information about the shift of the frequency is called as Doppler effect. Now, when an object is coming towards you, it's approaching you, naturally the frequency will be higher. You can see if a train is coming towards you, the volume is very high. But if the train is going away from you, the you can see if it is honking, the speed of that, or the frequency or the loudness of that entire horn is less if it is going away from you, and when it is approaching you, it is higher. So that is what is a Doppler shift. Doppler shift can be used with respect to sound, with respect to light. Wherever a frequency is involved, it can be used. Now here, when the object is coming towards you, it's approaching towards you, we call it as a blue shift. Remember, blue means the frequency is very high. Red means the frequency is lower. So when an object approaches you, then the sound which is coming towards you, or the frequency which is coming towards you, is like compressed. So it becomes high frequency. Whereas when object is moving away from you, then it's like a spring which is getting elongated. So naturally the frequency falls down. So this Doppler effect, by this effect, the radar is able to detect that object is approaching towards it or it is going away from it. So this is what we will be talking about: blue shift, red shift, about the compressed waves, and about the spread out waves. So this all information has been detected by the radar. So here, MTI radar. Now we know it is purely based onto the Doppler effect. Now whatever echoes it is receiving after reflecting from the target, that will be deciding that the target is coming towards you, it's going away from you, right? What is the speed of the target, right? So this part will be taken care. That's the reason we call it as moving target indicator. It totally works on the principle of Doppler effect. Now here, how does it work? Again, we have a block diagram of this MTI radar. The duplexer, again we know, is always acts as a switch, right? So when a signal, when the information has to be transmitted, then duplexer turns on the transmitter and turns off the receiver. Why we do so? Because when the transmitter is sending signals, the frequency is very, very high. This very high frequency need not to go to the receiver, because if you compare the received signal and the transmitted signal, the received signal is always having a less strength as compared to the signal that has to be sent onto the antenna. Very naturally, the antenna, the signal has to travel a very long distance. So naturally, the power needs to be high, the strength of the signal needs to be high, then only it gets transmitted for a longer distance. So now for that, what all things are needed? We need a power amplifier. Now this power amplifier will create a very, very high frequency, microwave frequency. This chylastron is a crystal which produces very high frequency microwave frequencies. So we are producing very high frequency with the help of this power amplifier. Then pulse modulator basically helps this to produce the constant oscillations that will strengthen the signal, that will be again powered up onto the power amplifier, and further it goes to amplifier. Now once it goes to the amplifier, we know that duplexer will send it to antenna, and antenna will send it to the space. Now here, a local oscillator that is producing a standard frequency, constant frequency. So we also call it as a STALO, that is stable local oscillator. This produces a frequency which has been applied to both the mixers. Now here the mixer plays a role. Now when the signal is being received, we know the duplexer is going to turn off the transmitter, turn on the receiver. We have also seen that mixer produces the sum and difference of the signal. Now, what signal are we talking about? We are talking about the Doppler shifted information or Doppler shifted frequency that we have received is compared with the frequency that was being sent. So naturally, there is a shift between what we have sent and the echo that is being received. That sum and difference is being produced by the mixer. Now to this mixer, this local oscillator gives a constant oscillations that is stable oscillation, so that this mixer one gets a reference value. Now, one more thing we need to know that this output of magnetron oscillator, which we have seen is giving a very high frequency, is also been given to the mixer one. Again, as we said, we want to maintain the very high frequency. Now, this high frequency, which is produced by Stallo, also helps in producing IF amplifier. And so the advantage that we get is that the phase of this coherent oscillator output will be locked to the phase of the IF signal, which means this coho, that is coherent oscillator, which is also giving a very high frequency to phase sensitive detector and mixer 2, will be having a fixed phase difference or fixed phase that will help us to produce this difference. Now here what is happening is this coherent oscillator, as we said, is giving this oscillations to both the mixer, so the phase sensitive detector and mixer 2. And mixer 2, what it is doing, it is producing sum and difference of frequency, just like mixer 1. Since in mixer 1, we are giving a stable constant oscillations. In mixer 2, we are getting an oscillations, very high frequency oscillations again. So the difference of Stallo and Coho can be seen in mixer 2. Now further, this IF amplifier, which we know that was been produced by mixer 1, will amplify this only IF frequency that has received because of the difference. Now further, this IF amplifier, the output goes to phase sensitive detector, and this phase sensitive detector is interested only to detect the phase difference. Now we know how this phase difference has come. It has come because the signal that is being received, the echo that is being received, is with a shift. Now this Doppler shift has to be traced out from the original frequency. That is being done by the help of phase detector, with the help of coho, and further this high frequency also goes to mixer, which in turn goes back to the transmitter. If you see here, it acts as a loop. Now, whatever signal we have received, we know the target is continuously moving. Say it was in position A when it started. We received a signal. Now, this received signal went back to mixer 2, and it gives the information to your transmitter. By the time the target has moved from A to B, now B becomes a reference and the information goes back. Now the target has moved to C. So like this, the every information that is been received is also given as a reference to the transmitter, so that it keeps getting the idea that object is moving in a particular direction, and then only that difference of Doppler shift will be detected. We have one more block here, that is a delay line canceller, which itself is a filter. The main aim of this delay line canceller is to eliminate the DC components that are present in the echo signals. Now, when these DC components come, they come when the signal or the signal that has been sent is reflected from the stationary targets. We know that our target is moving. Say an aircraft is moving. It's moving in a space, or it is moving in a particular terrain. Now, in that terrain, there can be mountains, there can be trees. Now, the reflection that was being received by the mountains, by the trees, which are the fixed stationary targets, that is being received and which has been cancelled, because we are interested to find only the moving target, right? So by cancelling this, we get the information only about the moving target and non-stationary targets. So stationary target received signals are been cancelled by the delay line cancel. It has been filtered. so that we get the information only about the moving target. So that is how moving target works. Now there is one more thing that needs to know, which is known as butterfly effect. Now what is a butterfly effect? Now if you look at this particular graph, you will find that this first part, you will find it looks exactly same from A to F. Whereas where this blue arrow comes, here you can see there is a small variation in from A to F. Now again, if you see the next position, it looks the same from E to F. Again, if you see the blue indicator, you will find there is a small variation and from A to F. Again, you will find other places it is exactly same. What is it? This is basically wherever you get the fixed output from A to F, or I should say A to E, that is the stationary objects. But where the target is moving, you will find a change in graph A, B, C, D, and E. Again, where the object is stationary, you will find the same graph. But where the target is moving, there you will get the information like moving. You will find there is a variation in the graph. Now in F, you will find we are actually merging all the graphs that we have received from A to E. And when we sum it, you get the graph which looks like a butterfly. So it is called as butterfly effect or butterfly graph. This is basically needed for the moving target information. So with the looking at the graph only, you can yourself identify which one is a stationary object and which one is a moving target. So this moving target indicator is not only for the aircrafts and submarines, even the clouds. Moving clouds can also be traced with it. So this was all about MTI. Next, we will go to continuous wave radar. Now, in continuous wave radar, the name itself says that we are going to send continuous waves. Okay. Now here, again, we can use the Doppler effect. Doppler effect, it can be used anywhere. Okay. Now, with the help of continuous wave radar, you can also find the Doppler shift happening in the signals. So in MTI, what we have done, we have used pulses, we have used Doppler effect, and then we have traced out a moving target and the stationary targets. Now here with continuous wave, again, you are able to uh, detect the non-stationary targets that are moving targets with the help of Doppler effect, but continuous waves. Only difference between MTI and continuous wave is in MTI we used only same, we have used only one antenna which was used with the help of duplexer, and the same antenna was used for the transmitter and for the receiver. But in continuous wave we go with two antennas, one is for transmitting and one for receiving. So when we are using two separate antennas, naturally role of duplexer is not there, because duplexer is used only for switching between transmitter and between the to shift between transmitter and receiver. Now, in continuous wave radar, since we are using two different antennas, one is used only for transmitting, other one is used only for receiving. Now here, again, when one thing is fixed, that whenever you want to transmit a signal, the strength of a signal should be very high, the power should be very high, the frequency should be very high. So here we are for continuous wave transmitter, we need to have an oscillator which produces analog signal with a very high frequency. And then this output of transmitter is connected to both your antenna and with mixer 1. Now here we are having IF oscillator, which is producing a particular frequency, say Fi, and they say just for the namesake, we are saying Fi. And this again acts as a local oscillator and gives a constant frequency to the mixer. Why is this done so? So that the difference, we know that mixer mostly works on the difference and sum of the received signal and the reference signal. So that is the reason these two things have been given here. Now, when whatever signal is been transmitted in a space, it's also been given to the mixer. So naturally, and a reference point is also given. So naturally, whatever is received by the receiver antenna will be having a Doppler shift. So naturally, the signal sent by a transmitter acts as a reference for the signal that is received with the Doppler shift, and the comparison again happens at the receiver mixer. So with that, the difference between the difference or of that original signal that is sent and what is received, that difference can be traced out, and we call it as a Doppler shift. Now this shift is been or that frequency that has been produced by mixer is been given to IF amplifier. IF amplifier will just amplify the IF amplifier, and that helps to trace out only Doppler frequency. Now what continuous wave is doing? It is only giving an output in a form of a Doppler shift. So now with this, now either you can use an audio amplifier or you can use a video amplifier, and either you can see the display or you can see it, you can identify with the help of audio amplifier. So that is the role of continuous wave radar. So we have seen that total there, how just a small recap of what we have done till now. So we have seen that various pulses are being used. One is we are using we are using pulses for fixed target and moving target. For fixed target, what we have seen that we are tracing out the target which are fixed, like we have seen the example of terrains, mountains, then mines, which are fixed where the geostationary satellites are being used. Then moving target indicator we have seen with the help of Doppler effect, we are able to trace out the object is moving towards us or going away from us, what is the speed of the target. All that information was able to trace out with the help of the MTI radar, where we were giving the pulses in a form of a we were giving signals in a form of pulses. We also a delay line canceller which prefers to cancel all the stationary echoes that we have received, and this all is being figured out with the help of the butterfly effect. Now we have seen continuous wave. We are focusing on to the non-stationary targets, but here we are using continuous wave and Doppler effect. The difference between the pulse radar and continuous wave radar is in pulse radar we can use one antenna for both transmitting and receiving. So we need a duplexer. Whereas in continuous wave we are using two separate antennas, one for transmitting, one for receiving. So duplexer is not required. So now here the purpose is we are interested only in the shift. We just want to know that object is moving or coming. Is it a blue shift or a red shift? Further informations we are not opting right now. So it can be heard in a form of audio or it can be displayed as a video. Now one more that we are having is continuous wave radar is FMCW. The name itself says we are going to go ahead with frequency modulated continuous wave radar. Frequency modulated continuous wave radar, or it can also be called as continuous wave frequency modulated radar. Now here, as we said, whenever we use the continuous wave, we are going to use two antennas. So here, what is the purpose of this? Is again, we are interested in altimeter. What is altimeter? Altimeter basically tells us about the height. So this radar is going to detect at what height this object is moving. Okay. So now here, again, we have two radars. One is for transmitting, one is for receiving. We have FM transmitter that will be sending a very high frequency towards the antenna. We have FM modulator, which will be working on the principle of FM modulation.